Hi everyone, welcome back to Himanshu AI Labs. In the previous video, we explored NLP pipelines like sentiment analysis and text generation. Today, we will go beyond text and work with audio and computer vision pipelines using Hugging Face. I would suggest you to watch the previous video. If you haven't watched the previous video, pipelines are simple abstraction that lets you use pre-trained AI models with minimal code. As we have seen in the previous video, the input goes to the pipeline and we get an output. The exact same idea applies to audio and images as well. Instead of text, we can now provide an audio file or an image as input. Let's start with speech recognition. Here the model converts spoken audio into text. Before we jump into the code for speech recognition, let me do some quick imports. Import warnings dot filter warnings ignore. I am suppressing warnings here just to keep the outputs clean for the demo. Next we will import the pipeline utility from the transformers library. From transformers import pipeline. We are good. Let's create an object transcriber equal to pipeline and the task automatic speech recognition, and let's define the model also. Model here is OpenAI's whisper model, whisper small. Let's upload our speech now. Let me play this audio for you. The quick brown fox jumps over the lazy dog. Transformers pipelines make machine learning simple and powerful. Let's pass this speech audio to transcriber. Result equal to transcriber speech.mp3, which is our input file. We will print the result. Print result text. Enter. As we can see, the output text is the quick brown fox jumps over the lazy dog. Transformers pipelines make machine learning simple and powerful. This is exactly what we had in our speech audio file. The model listens to the audio and automatically generates the transcription. Speech recognition is widely used in the industry for applications like voice assistants, meeting transcription, automatic caption generation, etc. Next, let's classify audio. Instead of converting speech to text, this model identifies what type of sound it is. Let me create object classifier this time. Classifier equal to and call pipeline. And task here is audio classification. And the model we are gonna use here is this one. Let us upload an audio file again. Let me pick test sound file. Let me also play it for you. Clearly this is a dog's barking sound. Let's pass this in the classifier and see what our model identifies it as. Result equal to classifier test sound dot mp3. Print result. The model gives multiple related labels. Let me pick the top three. Let's run this. As you can see, the model predicts labels along with confidence scores. For example, it has predicted the label animal and the confidence score, dog and the score, and bark. All these labels are relevant with our audio. Audio classification is used in many real-world applications like speech detection, music recognition, security systems, etc. So far we worked with audio. Now let's move into computer vision and see how AI can understand images. Image classification predicts what is present inside an image. For example, if I give a dog's image as input, the model identifies it as a dog's image. If I give a cat's image as input, the model classifies it as a cat image. Let's create the classifier again and pass image classification to the pipeline. Let us upload our image. Clearly, the uploaded image is that of a cat. Result equal to. Let's pass our image to the classifier image.jpg. Again, let's print the top three labels. Print result 3. As we can see, the identified labels are Egyptian cat, tabby cat, and tiger cat. All of these are similar breeds of cat. Image classification is widely used in applications like medical imaging, facial classification, etc. Now let's take one step further with object detection. Instead of just predicting one label, object detection identifies multiple objects and their locations. The model detects objects and draws bounding boxes around them. We first create an object detection pipeline and pass an image to it. Detector equal to pipeline object detection. Let the model download. Next, let's upload this image, traffic.jpg. Let's view this. This is a busy street scene containing multiple objects such as vehicles, pedestrians, traffic lights, etc. Now let's use this traffic image. Result equal to detector traffic.jpg. Let's print what we got in result. Print result. Notice that the output contains the detected object label, a confidence score, and the coordinates of the bounding boxes. The model analyzes the image and returns all detected objects along with their location and confidence scores. Using these coordinates, we can draw bounding boxes around each detected object. Let me write the code for it here. I won't go into the explanation of the code. You can pause the video and try out this code on your own. Let's run this. As we can see, the bounding boxes have been successfully drawn around the objects in the scene. Let me open the object in new tab and zoom in a bit for better clarity. It's clearly visible here that this car is detected. Even the person driving the car is detected. Other objects like bicycle, another car, this truck, different pedestrians, bus, all of these are correctly detected by the model. Also, all the bounding boxes have corresponding labels around them. Let's look at few real-world applications. Object detection is widely used in self-driving cars, smart surveillance, traffic monitoring, robotics, and for many more applications. One of the coolest vision tasks is image captioning. Here the model automatically describes an image in natural language. For example, consider this image of mine. The model can describe this image as something like a man standing on a beach near the ocean. For image captioning, we will use the Blip image captioning model from Salesforce. Captioner equal to pipeline image to text model equal to Salesforce and blip image captioning base. Then result equal to captioner image2.jpg. Print the result. Print result. The model has generated the caption, a dog lying on the grass in a park, which describes this image. There are various real-world applications for this. For example, image captioning powers photo organization in galleries and enables AI assistants to understand and describe images. In this video, we explored audio and computer vision pipelines using Hugging Face transformers. If you enjoyed this video, consider subscribing to my channel for more practical AI contents. Also, do let me know if you need anything to be covered in my next video. Thank you.